Anthropic quietly removed over 80% of Claude Code's system prompt. And the AI didn't get dumber. It stayed exactly as smart on coding tests. Beat. Welcome to this deep dive. Today we're unpacking a fundamental shift in how we work with artificial intelligence.
It really is a massive shift. The whole era of brute force prompt engineering is just fading away.
Right, we're moving into something much deeper. It's called context engineering.
And it changes everything about our daily workflows. We're so used to treating AI like it needs this constant, overbearing supervision.
Like it can't function without us holding its hand.
Exactly. The older models needed that. They required giant, rigid rule books and just endless repeated examples to work right.
But the newer Claude models are structurally smarter now.
Way smarter. They have an entirely different level of baseline reasoning. So if you hold on to that old, bloated setup, you're quietly making your workspace slower, heavier, and honestly, incredibly expensive.
So today we're going to walk through 6 specific shifts to clean up a Claude Code workspace, making it thinner and easier to navigate.
Yeah, it's going to be super practical.
But before we tear into the mechanics of those 6 shifts, let's establish a clear baseline. When we talk about context in this new era, what are we actually referring to?
It's a good question because people confuse it with the prompt.
Right. Think of it like this. Context is the tools, routines, memory, and reference files surrounding your prompt.
Yeah, the prompt itself, like the text you actually type into the chat bar, is just the tiny tip of the iceberg.
The real magic comes from the unseen environment you construct around it.
Exactly. If the environment is cluttered, well, the AI's reasoning gets cluttered too.
So let's get into the first major shift. This is about moving from dictatorship to collaboration. In the past, we treated AI like a fragile machine.
A machine that needed strict, absolute rules.
Yeah, we'd write prompts that shouted things like, never write comments under any circumstances.
We kind of had no choice back then, honestly. The older generation of large language models, they had a much lower threshold for reasoning.
They were easily confused by ambiguity.
Totally. If you gave them a wiggle room, they'd hallucinate or fall into really bad, repetitive habits. We had to build these rigid, authoritarian guardrails just to get usable code out of them.
But models like Claude 3.5 Sonnet process information differently now.
Right, they have a massive grasp as nuance.
It reminds me of managing a junior employee. On their very first day, you give them step-by-step micro-instructions. Do this, then click that, then save the file exactly here.
But as they gain competence, you stop micromanaging. You trust them to read the room.
Right.
You give them principles, not rigid rules. So instead of hard coding a command like never write comments, you give it a guiding principle.
Like match the comment style of the surrounding code.
Exactly. Or instead of demanding one exact formatting structure for a Python script, you just tell it follow the naming conventions already established in this repo.
You're giving the AI the space to actually use its judgment.
Yeah, based on what it sees in the wild.
But wait, does giving it less specific rules actually risk making the output less consistent? Like, what if the surrounding code is just a total mess?
That's a totally fair concern. But honestly, the opposite happens. When you give an advanced model rigid rules, it applies them blindly.
Right.
It forces a square peg into a round hole because you ordered it to, which creates brittle code. But when you give it flexible boundaries...
Like instructing it to inspect nearby files first.
Exactly. You anchor its reasoning to the reality of your specific project. It stays incredibly consistent because it's adapting to the situational context rather than fighting against it.
So guiding its judgment works much better than trapping it in rigid rules.
It leads to much more robust systems. And trusting that judgment forces us to rethink how we manage its creative output, too.
Which brings us to a huge change in how we handle design and aesthetics. We used to rely heavily on examples here.
Oh, heavily.
Yeah, if I wanted a new landing page, I'd feed the AI 3 URLs of websites I liked and say, build something like this.
But looking at the source material, they're strongly warning against this now. If you give Claude 3 website examples, it just mimics them.
The actual range of creative ideas completely shrinks.
The model suffers from a sort of mode collapse when you do that. It assumes you want a literal clone of those specific examples.
So it narrows its probabilistic focus entirely.
Right. Stops inventing and starts copying. To fix this, we need to introduce what's called a design interface.
Meaning, instead of giving it exact copies to trace, you're building a sandbox.
You're defining the boundaries of the playground. You give it the brand colors, the fonts, the brand voice, and the core layout rules.
The source outlines a brilliant workflow for this, actually.
Yeah, it does.
You ask Claude to generate 3 distinct design options based on your brand identity. You pick the best one, refine it together, and then, here's the crucial part, you save that specific layout as a foundational file.
Something like brandbook.html.
And then you hook that into your daily automation. You connect that HTML file to a reusable skill command.
Let's say you name it /robo.
Right. From then on, every single time you need an asset, a slide deck, a UI component, whatever, you just fire off that /robo command.
And it pulls up the brand boundaries perfectly.
But wait, how does setting rules for fonts and colors prevent it from just creating the same boring layout every time?
Well, think of it as constrained creativity. The borders are fixed, so your brand identity is completely safe. The logo won't suddenly be neon green.
And the padding won't be broken.
Exactly. But inside those borders, the AI has total freedom to combine those approved elements in novel ways. It can introduce kinetic dots or animated typography.
Entirely new interactive grid layouts that you never explicitly asked for.
Right, because it knows the absolute rules of the playground, so it can run as fast as it wants without hitting the fence.
Boundaries prevent cloning. It creates freely, but safely within your exact brand guidelines.
Now, setting up that brand book file is brilliant, but we run into a massive bottleneck if we don't manage it correctly within the broader system.
Right, because if you take that brand book, your coding standards, your roadmap, and you dump all of that into the main AI workspace...
You're going to completely bankrupt your token limits.
Yeah, the old habit was incredibly expensive. Developers would stuff absolutely every note, every rule into one giant file.
Usually called Claude.md. It felt incredibly organized at the time, everything in one centralized place.
But the AI doesn't read a file like a human does. A human skims for what they need. Every single time you start a session, the model is forced to load and process that entire massive file.
From top to bottom.
Let's define a technical term here, just to be clear. Tokens are the basic units of data an AI reads and bills you for.
Right. So if your Claude.md is a sprawling 10,000-word document, Claude is burning thousands of tokens before you even type hello.
It's wildly wasteful.
And beyond just draining your wallet, it actually degrades the model's performance. When an AI holds too much irrelevant information in its active memory, its attention heads get diluted.
It suffers from the lost in the middle phenomenon.
Yeah, it struggles to focus on the immediate task.
The architectural fix for this is a concept called progressive disclosure. It means your main file shouldn't be the encyclopedia.
It should just be a thin router. It's essentially a map. That main file should only ever answer one fundamental question. Where should Claude look next?
So instead of pasting all your writing rules directly into the main file just holds a pointer. It says, for writing rules, look at content.-md.
Or if you need the product roadmap, go open product.-md. You're giving it the index.
If it needs pricing data, it's routed to business.md.
Exactly.
I'm trying to visualize this workflow. Doesn't it slow Claude down if it has to hunt for the right file instead of having it right there?
Well, mechanically, yes. There's a tiny fraction of a second spent retrieving the file. But practically, it speeds the entire process up exponentially.
Because it saves money and limits usage hits by only loading exactly what is needed for that specific task.
Right. It preserves the model's attention heads exclusively for the logic of the code you're writing. It doesn't wade through your marketing strategy when you just want it to debug a Python script.
It's like a librarian giving directions rather than carrying the whole library.
That's exactly it. And once you start splitting everything into specialized files, a glaring issue usually bubbles up.
You start noticing how often you're repeating yourself across the system.
Which brings us to the concept of context rot and the fourth major shift, cutting repeated instructions.
I'll admit, I still wrestle with messy AI memories myself.
Yeah.
I catch myself repeating instructions just out of paranoia.
We all built that habit out of necessity, honestly. In the older days of generative AI, models suffered heavily from context rot.
Right.
Over a long chat session, as the context window filled up, the model would literally push early tokens out of its active memory.
It would hyper-focus on the most recent messages.
And completely drop the structural rules you gave it at the beginning of the day.
So as a survival tactic, I'd put a core rule in the system prompt. Then I'd put it in the tool description. Then I'd add it again at the top of the workflow file.
Just begging the machine to remember what you wanted.
Exactly.
It made the setup safer 2 years ago. But today, it just adds unnecessary weight. Modern models like Claude 3.5 have incredible recall across massive context windows.
They don't suffer from that same aggressive attention decay.
Right. So when you repeat those instructions, you aren't helping the model. You're just burning tokens and cluttering its processing.
The source is adamant about this. Keep one clear version of a rule, period. If you have tool descriptions, they need to be ruthlessly stripped down.
Tool descriptions only need 3 specific things: what the tool does, when to use it, and what result to expect.
No extra fluff.
No repeated warnings about edge cases, just the functional mechanics.
So if we delete the redundancies, how do we know which specific file is the safest place to keep the single remaining rule?
You place it where the AI's attention is already going to be focused. You keep it in the place where Claude actually needs it most for the specific task at hand.
If it's a strict coding standard, it lives in the coding router.
Yeah, if it's a tone of voice rule, it lives in the writing router.
Yeah.
Keep the context as close to the action as possible.
Keep it simple. Store the rule exactly where the AI does the actual work.
And when you stop manually plastering rules everywhere, you can actually start automating how the AI remembers things moving forward.
This is the 5th shift in the new paradigm, moving from a manual memory system to an automatic memory system.
Oh man, the old way was tough.
I remember it vividly. You'd be deep in a session, figure out a great workaround for a bug, and you'd have to manually hit the pound hotkey.
To physically tell Claude, hey, save this lesson into Claude.md so you don't forget it tomorrow.
It was functional, but it relied entirely on human discipline. You had to remember to save the memory while you were in the middle of complex problem solving.
Which is hard.
Yeah.
Usually we either forgot or we got lazy and just saved the entire messy chat transcript.
Turning the memory file into a complete disaster.
Yeah. The new workflow they're suggesting is so much more elegant. It treats the end of every single work session as a dedicated, automated cleanup step.
You build a specific skill command for this. A lot of developers call it /calibrate.
Right. After a successful coding session, instead of just closing the window, you run that skill.
You're essentially telling Claude, review our entire session today.
Extract any useful lessons, any workflow changes we figured out, or any reusable prompts, and save them into the correct memory files or routers.
It's like asking the AI to sweep the floor and organize the tools before it turns off the lights in the workshop.
It synthesizes its own thoughts, parses the chat history, and updates the routers automatically. It keeps the system's memory genuinely useful instead of just becoming a graveyard for half-finished thoughts.
But wait, how do you prevent the calibrate skill from just saving a bunch of useless garbage from the chat? We all have those moments where we go down a rabbit hole that turns out to be a total dead end.
Yeah, nobody wants that.
I don't want the AI saving my mistakes.
You have to explicitly instruct it to filter. In the background prompt for the /calibrate skill, you literally add a directive that says, keep only what will help future work.
Discard dead ends, failed experiments, and conversational filler.
Exactly. You force the model's reasoning engine to evaluate the actual utility of the memory before it writes it to a file.
Got it. You actively command it to filter out the noise and save gold.
And now that we have the AI automatically saving its own memories, we have to upgrade the actual format of those files we're saving.
Which is the 6th shift, upgrading to richer references. For a long time, everything in an AI workspace was just Markdown.
Simple text files.
And Markdown is fantastic for logic. It's lightweight, it's perfect for rules, technical specifications, or basic checklists.
It's easy for humans to read and cheap for AI to process. But for visual work, Markdown is terrible.
Yeah, you cannot easily describe a complex multi-column visual layout or the spatial relationship between UI elements using simple text headers and bullet points.
That's where HTML completely changes the game. The newer Claude models can handle richer references natively.
They don't just read the text.
Right. They can read the raw HTML code and actually understand the visual hierarchical structure it represents through the document object model.
And this is the brilliant part. You can open that exact same HTML file in a web browser. You can see it visually.
The AI reads the underlying code structure, you look at the rendered visual on your screen, and suddenly you are both speaking a language that bridges raw data and final aesthetic output.
There's an example in the source that just blew my mind. You can ask Claude to take a dense, abstract concept and turn it into a clean, interactive HTML infographic. 2 sec silence. Whoa. Imagine distilling 2,000 words of dense meeting notes into one visual HTML file that both you and the AI instantly grasp.
It completely alters how you store complex knowledge. Instead of Claude burning thousands of tokens reading through dense linear text every single time, it references an optimized structural map of the information.
It is exponentially better for brand books, visual design systems, and complex layout rules.
Unbelievably better.
I get that it's amazing for layouts, but Is HTML only useful for visual things like brand books, or does it change how it thinks about logic too?
For pure logic, like a Python scripts architecture or a backend database schema, Markdown is still your best bet.
Keep it lightweight.
Yeah, HTML is really best reserved for spatial and visual systems. Things like UI spacing, grid alignments, or structural infographics, where plain text just cannot convey spatial relationships clearly.
So Markdown is for logic, but HTML is the ultimate tool for visual systems.
That is exactly the dividing line. So we've walked through all 6 of these shifts, moving to principles over rules, using design sandboxes, setting up progressive disclosure routers.
Cutting redundancies, automating memory cleanup, and using HTML for visuals.
But theory is one thing. How do you actually apply this to a workspace that's already a tangled mess?
We need an audit. The final piece of this puzzle is the built-in diagnostic tools, the /doctor and /doctor plus commands.
Anthropic built these commands specifically to find the dead weight that is quietly slowing your system down.
What exactly is it hunting for when you trigger that audit in your terminal?
It checks for a few major bottlenecks. It looks for unused skills that are just taking up space. It scans for dead MCP servers.
Let's define that one quickly for anyone new to the architecture. Connections linking AI to external tools.
Perfect, yeah. So if a database connection is broken, it flags it immediately. It also highlights bloated main files or hooks that are taking way too long to execute.
And if you run the upgraded /doctor plus command, it actually evaluates your entire setup against the exact 6 context engineering shifts we just broke down.
The source highlights a really specific scenario for this. Imagine you've built a research skill that has grown over time to be over 2,000 lines long.
If you run the audit, the doctor command will flag it.
It will tell you the file is too thick for efficient processing and suggest breaking it down into a router system instead.
It doesn't just throw an error code and leave you guessing.
No, it says, this is inefficient, and here is the exact architectural fix to make it faster. The standard recommendation is to run this audit once a month to actively reduce token waste.
Should you run this audit before or after you try to manually implement all the 6 shifts we just talked about?
Oh, definitely run it before making big changes. Let it generate the diagnostic report first, so you aren't just fixing things blindly.
It gives you a customized roadmap for your specific clutter.
Exactly. Let the system tell you exactly where it is struggling.
Run the audit first. Let the AI diagnose the exact clutter, slowing it down.
It's the smartest way to start.
We've covered some serious ground today. Let's pull the big idea together. The era of brute forcing AI is over. You cannot just hand these advanced models giant, heavy rulebooks and expect brilliant results.
The micromanagement actually slows the reasoning engine down. A powerful workspace is a light workspace.
You give the AI clear principles instead of rigid rules. You build design sandboxes to keep it creative but contained.
You turn your main system file into a router that simply points to information. You ruthlessly clear out duplicate instructions.
You automate the memory cleanup process.
Yeah.
And you leverage rich references like HTML when you need to convey visual space.
It's a massive evolution in how we interact with these tools.
And honestly, for anyone who uses AI daily, it's a fascinating philosophical shift. To get the absolute most out of these incredibly advanced systems, we actually have to step back.
We really do.
We have to let go of our need for total micromanaged control. Less clutter truly equals deeper capability. So as you look at your own workflow today, ask yourself, in your own workflow, what over-engineered rules are actually holding you back from doing better work?